From the American Museum of Natural History in New York City and beaming out across all of space and time, this is Star Talk, where science and pop culture collide. This is Star Talk, and I'm your host, Neil Degrasse Tyson, your personal astrophysicist, and today is Cosmic Queries, Planet Edition. But we don't just stick to planets. This one is planets and stuff. And today I've got Paul Mecurio with me. Paul.
How are you? Good
Welcome back.
You. Thank you.
You're damn near irregular.
I please. That's all I want to do.
No, I didn't call you irregular, irregular. Did I pronounce that? Did you hear?
But actually, I kind of am a little bit, but we can get into that later. I have a couple of questions about how I can fix that, but we'll deal with that later.
Fix the irregularities.
Exactly.
Great to have you on this.
Yeah, so glad to be back. Thank you.
And our normal format is we solicit inquiries from our fan base on different platforms, and the questions come in. I haven't seen them yet.
Right.
This is not Stump Neil Day, but it's if I don't know the answer, I'll say next one, please.
I've never seen you have to say next one.
No, usually I have something to say about it, even if I don't fully know the answer.
Exactly.
Just to tell people, did we first meet at Stephen Colbert?
We first met at the
because you're the warm-up guy.
Yeah, I warm up on that show. I was a writer on the Daily Show.
Oh, that go even further back.
Yeah, and then the Colbert Report, and I just came to say I was a big fan once. You were very nice, and then I came back the next time. I asked for a loan. You said no. Mr. Big Shot doesn't have any extra money. Okay, and then you were nice enough to come on my podcast, which has still gotten like one of the top listens. It's
really
so
excellent.
Fantastic. Yeah, we talked
Excellent.
about dark matter and all this other stuff, and then you asked me for money for that, and I'm like, that's inappropriate. I don't have any money. You have them. No. So we go back.
And, so it's great. It's great to have you and see. And we are reporting now from YouTube, New York City, in the Google building.
Yeah, this is such a cool space.
At a YouTube production space, and so they're kind enough to. So I miss all my books behind me. Maybe I can have like a plastic version of it, just slide it in.
You could have them photoshopped in later. And it's right above the Chelsea market. I got like a ham sandwich in my park.
Oh, yeah. You can't walk through without buying food.
I know, exactly.
Yeah, I don't know why any skinny people exist in this building. That's not possible.
There's actually a Weight Watchers office here. It's pretty weird. No. But yeah, it's great to be here. And it's a really cool space. I didn't know this was here.
Yeah,
And I always say, and I'm going to say it again, if I had you as a science teacher, I'd be doing science today.
Really? Seriously?
I say that. I don't.
Wow.
Yeah, right, Carol? I don't. Yeah, that's my wife. And because you make it accessible, your personality, it brims, you brimming with sort of, you love it. And you explain
You know what
it
Carl
in a way
Sagan
that's
said? He said, when you're in love, you have to tell the world.
Right. I had a 8th grade math teacher, this big hulking guy. He smoked in the class, and he was like, and we made a battery. Like, that was the big thing. Like,
okay.
Right? No, you put the thing over there. It's like this. Like, it's like he was like one step away from going to off-track betting. You know? and I just remember being intimidated by him. And I think people are very intuitive from a young age and can sense if somebody cares or doesn't care.
Oh, yeah.
And he did not. And that's why I think
Okay,
you're
well,
so
thank
great
you.
at it. Yeah.
And just
look at me. I love you, man.
I love you, man. It's not your fault. It's not your fault.
It's me.
Just a little bit back at you. I deeply respect your profession.
Oh.
The people who take information in the world, reshape it, hand it back to you in a fresh perspective, and make you laugh at it.
Well, thanks.
These are very special mirrors, and I don't know how bearable society would be without them, without the comedian who occasionally shows up and said, "You realize this is what you've been saying?" And oh my gosh, and
right.
So this is why comedy is a fundamental part of what we do on Star Talk.
Yeah, well, thank you. I mean, when I started on the Daily Show, we were just this little show, and we were just doing jokes and didn't really say, okay, we're going to have an impact on the world or whatever, right? And then things started to happen, and we were always factually based in our jokes,
in the comedic, yes,
right?
sure.
So you have to start with the premise. So we were delivering the news with a non-biased point of view and just saying, this seemed a little strange to you? So over time, people would come up to us and go, I only get my news from the Daily Show. I go, well, first of all, we're a bunch of idiots. I don't think you should do that. Read some papers.
So you say, what the hell's wrong with you?
Yeah, exactly. Read a couple of newspapers. But it did end up becoming that. And then, from that, the Colbert Report, the Late Show, John Oliver's show, Sam B's show.
Yeah, the whole universe.
Yes, is all sort of carrying that mantle of let's call people, to the carpet. And so, so thanks. Yeah, it was a nice byproduct of trying to have some fun.
Yeah.
And we get in so much trouble, too, because we would go too far with jokes.
Yeah.
And the president network would yell at us. But anyway, we'll talk about that another time.
So what do you got for me? You got planet questions.
I got some planet questions.
All
and
right.
some very good ones and interesting ones and questions and answers I want to hear. So let's start with Patreon.
Oh,
person.
yeah. I keep forgetting we do this.
Yes. He says,
We're just kissing up to the Patreon
Yes,
members.
exactly.
Yeah.
Ryan, you are so handsome. That shirt you're wearing looks fantastic on you. Write a check. Is it true that if one had an ocean large enough, Saturn would float?
So this is often said. I've said it. Colleagues of mine have said it. Let me restate that in a more scientifically precise way.
Okay.
All right? Because technically that can't happen. All right? You can't get a bathtub.
It would be one hell of a bathtub.
It would hell of a bathtub. I'll tell you why that couldn't happen in a minute. So the scientifically precise way to communicate that same information is that the average density of Saturn is less than the density of water. And anything whose density is less than water will float.
Okay.
So Saturn, so the technical way to say it is, if you scoop out a piece of Saturn, it will float on a puddle of water or in an ocean. It doesn't matter. So that's the way to say it.
Okay.
It's more fun to say, get an ocean or a bathtub big enough, Saturn will float.
Right.
And I've said that publicly, lamenting that when I was a kid, I knew this was true about Saturn. And all I ever had in the bathtub was a rubber ducky, and I really wanted a rubber Saturn. Because it was so later in my life, we come back to my office, someone mailed me a rubber Saturn.
Is that right?
Yes, I now have a rubber Saturn.
That's great.
And I want to leave it in my office. I don't want to take it home to my bathtub. But
honey, what's a rock doing in the bathtub? It's a long story.
So I've got a rubber Saturn. So the problem is, if you had a lake bigger than Saturn to put Saturn in, the whole lake would collapse into Saturn.
Well, wouldn't the water just spill over onto the shore when it displaced the water?
No. You're thinking that they exist independently of each other. Saturn will pull the bathtub into it, and it'll become part of Saturn.
Oh, it's got the suction power.
Unless, it's called gravity.
Okay, you
it's
didn't
an old joke.
It was a little condescending. You didn't need to say it like that.
It's an old joke. There's no such thing as gravity. Earth sucks. See, that's
Nice.
that's the old joke.
Nice. That's funny.
So what was I? Where was I? So the problem is, you can't have a body of water bigger than Saturn that's flat that you're going to put Saturn in. Because the body of water would become a sphere and they collapse, they fall into each other. All right? They each have mutual gravity that they'll attract each other. Okay. So it's not a doable experiment, but it does get the point across that Saturn is lighter than water.
Plus, Saturn would need a life jacket in case something happened.
No, that's what the ring is for.
Oh, come on.
Gotcha in that one. That's his little life preserver.
I'm getting out of comedy now. That's great. Okay.
Yeah, so it is in fact true. It is the only planet for which that is true. Every other planet would sink.
And it would absorb all the water.
And by the way, Jupiter is very gaseous, and its density is close to that of water, but just a little bit above it.
Now, how do we know this about Saturn? I mean, how?
So what you do, that's great. Good. Do we go there? No. So you know how big it is? Mm-hmm. So what is density? It's how much mass you have in the volume that you occupy. So it's literally mass divided by volume.
Okay.
Grams per cubic centimeter.
Okay.
Pounds per cubic inch. That's density. Mm-hmm. Those are the units of density. So we know the size of Saturn, and we know the mass of Saturn. We can measure it from its gravity and other things. Mm-hmm. You divide those two numbers, you get a number that's less than 1.
And that means?
In the right units. And the density of water is 1. Oh. Yeah, by definition, basically.
Oh,
yeah.
Okay.
Yeah.
So we know.
Yeah, it'll float.
All right. Okay.
And here's something I figured out about myself just a couple of weeks ago. I was swimming a couple of weeks ago, and I was floating more easily than ever I have in my life.
But you had a lot of hair. You needed a haircut.
Yeah, no, I'm just a little chubbier than I was when I was younger because fat floats and muscle sinks. That's the thing. It's about the density. Okay. How much mass are you packing into a volume?
So why do you think
you can say, how much does a whale weigh? Well, a whale weighs nothing. It's it's neutrally buoyant, floating, swimming in the water. You have to ask, how much mass does it have? It's why the biggest animals that ever existed exist in the water. They don't have to hold up their own weight against the gravity on Earth's surface. Wow. The whale is the biggest creature that ever existed in the history of life on Earth.
And yet it can float.
Because its density is about the same as water. If you are less than water, it would have to use energy to stay underwater because the water would want to make it float.
Which just happens to human beings.
Well, if you're chubbier, your body will float. Okay? Will float very well. Mm-hmm. And you'll take energy to go down below. If you are more dense than water, you will sink to the bottom and it'll take energy to stay afloat. If you're about the same density as water, you can move through the water with no, like the ease of a trapeze or whatever that line goes in the song. So following up on that, here's something interesting. Ready? Mm-hmm. You know who the smartest person in the world was? You raising your hand? No. One of the most clever people in the world was the first person to figure out you can build a ship, and everything you make the ship out of is denser than water, and it can float. You can build a ship out of steel and have it float.
That does blow me away when
It changed warfare.
And was it a specific
It changed. Wait, Paul, can you pause on that sentence, please? It changed warfare. You don't have to build your boat out of wood, right, which is susceptible to cannonball fire.
Right.
You can build it out of steel.
Right.
How do you get it to float? Because the part of the boat that sits below water is mostly air. The hull of the ship sits below water. Right. So what matters is not that steel is heavier than water and air is lighter than water. It's what is the average density of that which you have plunked in the water. It's the total volume divided by the total mass. It has less mass than you think because most of it is air. An aircraft carrier, most of its volume is air.
So it's able to float because of the relation of density of the water.
Correct. Anything that's floating is less dense than water on average, period.
And do you think that was by mistake, a byproduct of something else that somebody figured out steel can float?
No, they were making canoes out of wood because wood floats, and why would you make it out of anything else?
Right. But then the next step was steel.
In order for it to float, it has to have a significant amount of volume underwater so that the air can represent this. Right. Okay? Right. So
the larger the vessel, the deeper the hull for the most part?
Generally. It's not going to just be skimming. Right. It's going to sink in.
Right.
It's going to respond to the fact that there is steel there. Yeah. And then it'll come down to the level that's just right for what the weight is. If you look at container ships, they have these lines painted on the side of the hull, depending on how much gross weight it's carrying. So the more weight it's carrying, the heavier the thing is, the total density goes up, and it's going to sink a little lower into the water.
Got it.
Yeah.
And they know when they reach their max capacity.
Yeah, so ice is denser than cork.
That's counterintuitive in looking at ice versus cork.
Well, cork is from a tree, so it would float, but it's less dense because ice, evidence of that is the cork will float almost entirely above the water.
Right.
There's hardly anything sunk below it.
That's true.
Whereas ice, 90% of it is below the water.
Which is why you have icebergs.
That's why you have the iceberg problem. Yeah.
Wow.
And James Cameron in Titanic, he did it right. Okay?
Did he?
When they hit the iceberg, it's just a little thing in the water. It's a little thing.
Sticking out of the
Just a little thing sticking. 90% of it is underwater.
Right.
That's what cut up the side of the hull.
Right.
Oh my gosh. Yeah. Whereas in the first Titanic movie, the black and white 1940s, whatever, there's this huge iceberg out there. Oh my gosh. Okay.
Then it has a hand that reaches out
and cuts it.
It's got a knife.
It's in a knife fight.
It's like West Side Story on the ocean. Once a jet, always a jet.
So if you do the physics right, you don't need a big iceberg. And in fact, this has contributed to why it was one of the several reasons why it was so hard to notice. It's actually small.
Dark. It was foggy.
Dark. There wasn't any moon.
Right.
It wasn't foggy, but it was.
Right. Somebody was watching YouTube on their phone. Wait. We're going to move on. That's fantastic.
Oh, my favorite anachronistic quote is a quote from Abraham Lincoln, where he said, "Never trust anything you see on the internet." it's a meme. You gotta find it. And it's so beautiful. It's just you gotta love it.
You gotta love it. And coming from him, he's got a lot of credibility on it.
Yeah, he does.
I'll give it to you.
It's a man that knew what the hell he was talking about.
Yeah, the stovepipe hat, questionable choice there, but that and a buckle on a hat.
Yeah.
What do pilgrims need a buckle on a hat for?
He wasn't a
pilgrim.
pilgrim.
Out their
wait,
head?
excuse me. This is 200 years later. Would you get your time period?
I understand.
It was a top hat without a buckle.
But this is why my brain goes this way. Answer that question, smarty pants. Why do you need a buckle on a hat? Somebody letting their head out?
Well, no, you can squeeze it down in case the wind blows. It tightens up on your
But the
brim.
wind and the density and the volume and the wail.
Oh, I taught you too much.
You've created the master. The student has become the master. All right. You're going to eat that cookie later I gave you, right?
Wait, I got a quick one since we're talking about hat brims. Okay. Do you know the size of your own hat that you wear?
I have a pea head, pea brain pea head. I'm like 7.5 small. I have a small head.
7.5 would not be a small hat. That's a large hat. Yeah.
Don't argue with me about my
so you got a fat head. If that's your actual
no,
head.
No, it's like
no.
I have 6, and then it's probably 6.5.
Six, it could be. So here's
your head.
I have a fat head.
Yeah.
So here's
the building. It's really what it is. But anyway, go ahead.
So I don't know if you knew this, but that hat size has mathematical significance. Okay.
Please tell me it's not in relation to my you know what.
No, it's not. Not that I know that you know what I know. What you said you know what. So here's what you do. You take a tape measure and measure the circumference of your head.
Okay.
Write down that number. Divide it by pi. That's your hat size.
Oh.
Yeah.
I just thought it was that.
No.
You got to divide by.
Yeah, if the circumference of your head is 6.5 inches, you're some other species. You're a rhesus monkey. I don't know, but you're.
Well, my wife would agree with you about some other species. You don't want to see me with my clothes off. It's not pretty. Okay. Well, I just learned another thing because I just thought my head size was literally like you just measure.
No. You must have never really put those two numbers together. So I was in a hat shop because I always wanted to own a top hat that you can pop into.
Oh, yeah.
I always wanted to one, and they make hats. So they measured my fat head, and they wrote it down and said, you need a size 8 or something. So I said, fine. Do you know where you get this number? He said he didn't know. And I told him. He said, really? And so we did it. And so I'm glad that he was skeptical. So then you can do the experiment. We did it on his head and his assistant's head. It all came out. It was all perfect. And so he wanted me to write it out. So I wrote it out, and I signed it, and it's on the wall of his hat shop.
That's fantastic.
Yes. With the pie and the arithmetic.
Could you imagine him going home and like, honey, how was work? Well, this dude came in and we did math problems all day. But I sold a $400 hat, so I guess it was a good day. That's so awesome. You signed it.
It's on his wall. It's on the wall.
That's better than like a diner that gets you to sign a picture of
I know.
yourself.
Yeah. No, why would picture me? What is it? No, you want to put something that can advance human understanding.
That came from your giant ghoulish head.
Oh, now ghoulish is part of the adjectives.
This is my last time doing the show, by the way. All right.
Okay, we ran out of time to do a second question in this segment.
Oh, sorry.
So when we come back, we will continue with Star Talk, Cosmic Queries Planet Edition.
Bringing space and science down to Earth. You're listening to Star Talk.
We're back, Cosmic Queries. Second segment of 3. Paul Mecurio. Always good to have you. What do you tweet at what? What do you tweet?
At Paul Mecurio, 1 R in my last name, Mecurio. Yeah.
Okay, so good. There were no other Paul Mercurios in the Twitterverse.
Well, I had to change the spelling of my name because, no joke, there's an Australian actor, Paul Mecurio, and he got in the Actors Union before I did.
Oh.
So you can't have the same name.
Still, that's
so
still
I
the case.
dropped the first R in my name.
So Mecurio.
Yeah.
Yeah.
And
all
people
right.
still think I'm him sometimes. He's hosting a reality beer show in Australia.
That's a thing. Okay.
And so, yeah, he makes like craft beer. And so, like every couple
Craft
of
or
weeks.
crap?
No.
What? I missed the last
No, there's an
syllable.
F in there. Craft.
Craft.
Yeah.
Okay.
And I get every 2 weeks or so, I get beer recipes from people thinking I'm him.
Okay.
And I'm like, okay, that's not me. So anyway, at Paul Mecurio.
All
That's
right.
my thing.
Let's go for it.
Robert Weaver, also Patreon.
Good.
Thanks very much for continuing to educate and inspire us. What news and science do you find the most interesting or important? Is it the private space race?
No, I know too much about the private space race for that to be uniquely interesting to me. Things that interest me are things I know little about, and so that I want to know more about. I love watching the progress of neuroscience. I think the brain, our inner universe, in its attempt to contemplate the outer universe, presents one of the greatest intellectual challenges of our modern times.
And what advancements are we making right now that either surprised you or?
My view of the field, which is a very unpopular view among psychologists, is that the day will come when, I'm hypothesizing this, that the day will come where we understand the neurosynaptic phenomena in the brain with such precision that no one will ever have to lay down on a couch and spend an hour with a psychologist.
Because I do that. And seriously, and there's a lot of stuff I got to figure out and work out.
Right. And some of it, so maybe there's...
Let me tell you about my mother. So, no, go ahead.
So there may be things where people just need someone to talk to. That's one thing. But if you have some trauma or some issue that you can't shake or some addiction you can't overcome, I'm imagining there's a day we'll find the exact spot of the brain that's responsible for it.
And what would
that prevents you from pushing that next glass of highball away from you.
Or to go into depression or whatever it might be.
Or depression, especially depression, or anything else that lands you in one of these
funky states or whatever.
or one of these hospitals, in these mental hospitals. So that's the spot that's
Okay,
misfiring.
but what are we doing to the spot? Are we going in
No,
and
you've-
operating? Are we taking a medication? Or
At
a
this
certain
point,
time?
who knows? Is it too much firing, or is it not firing enough? Or does it has to be another path into it that connects to this other brain center that helps modulate it? I don't know.
Okay.
I'm imagining that a future will arrive where we have that much knowledge and control of what's going on in the brain so that you can just nip and tuck and fix all of these problems.
And why wouldn't psychologists welcome this theory?
Because they'd all go out of business overnight. Because you don't go into anybody's office for an hour and talk to them, not for an hour, for a whole suite of sessions that could go on for years that gets resolved in an afternoon.
I think my psychologist is making up a lot of stuff. I think I'm fine. I really do. And I think that, what do you
And
make?
it's not just the whole community. There's counselors and psychologists, psychiatrists, this sort of thing. We're kind of almost there.
Right.
There's a lot of depression that is not cured, but addressed by medication. All right. We know what chemicals will leave you in a depressed state, which ones don't, and why. Is it the production of those chemicals? Well, let's go in, adjust your genome or your neurosynaptic drivers in such a way that you're producing your own chemicals, so you don't need the pill.
Right, because the problem with some of these pills is there's this sort of whack-a-mole. You fix one problem, and then there's sort of byproduct symptoms of problems.
Correct,
Right?
because the pill gets ingested and it goes into your whole
Right,
system.
right.
Whereas if you surgically go in to one part of the brain for one. So now, one of the challenges to that future is the brain is highly interconnected to itself.
Okay.
So an ability expressed in one part of the brain, some of that is also in other parts of the brain, which is how you can compensate for some brain injuries.
It's not
you can
compartmentalized.
It's not as compartmentalized as we'd want it to be for it to be a nice, clean thing.
Right.
And while we're on the subject, did you see the movie, what's the one with Scarlett Johansson and her brain powers increase
Yeah, I can't
throughout
remember
it?
the
Is
name,
it
but I know.
Lucy?
I think it's Lucy, yeah.
Lucy, yeah. So the entire premise of that film is that she takes some drug, turns out by accident, but it boosts her brain power, not to something she didn't or any of us don't already have. It just enabled her to access the 90% of the brain that you're not using, okay? Well, where did this whole premise come from? And by the way, there are whole scenes in this film of rooms full of psychologists studying her as a phenomenon. Okay. It comes from some guy 100 years ago or so, I forgot his name, forgive me, who through brain injuries and other aspects of, because you can't just go in and start poking around in someone's brain.
You can't? Jeez, all right.
You sound like you have been.
Yeah.
I got to stop that, cross that one off my list.
I got a guy in my basement.
You got a guy.
I got to probably let him go now. All right.
Yeah. So what he said was, what he published was, the brain is so complex, we know only what 10% of it is used for.
But how is
Well, excuse me, that became, we only use 10% of our brain.
But how do we know he's right? It's a theory.
No, you're in the wrong room right now.
All right, I'll leave then.
No, what he's...
No, I'm done.
I can't work like this.
Yeah, there's a band playing downstairs.
There is. In the YouTube music space.
Yeah, exactly.
It doesn't matter whether or not he's accurate, and he probably was accurate. He said, well, there's a language center here, and there's another... All he said was, the brain is so complex, we only know what 10% of it is used for. That's all he said. A completely innocent comment. We have much more to learn about the brain. It got re-quoted as, we only use 10% of our brain.
Oh.
This is my
how
point.
I know
you weren't paying attention to what I'm... Okay?
Sorry,
and if
teacher.
you think we use only 10% of your brain,
Right.
this is the mantra for teachers with students.
Right.
It's a very hard thing to correct
when
saying it incorrectly is what you want to hear.
Why do you think we want to hear that?
Because we want to believe that we all have potential we can grow into. Okay? Here's the underachieving student. You're just using 10%. Just keep working on using more of your brain. You have vastly more potential.
Right.
We're into potentiality.
Right.
All right? Especially in America.
Okay.
There's
Now
some
I'm
countries
going to teach you how to tie your shoe again, and you're 6 and 7 years old or whatever it
You've
is,
got the
but
potential. Okay.
You can do more.
So that then became the premise of this entire movie. She's now using 40% of her brain. She's now using 60%. And at 80%, she's like flying through web pages, learning whole dictionaries in a matter of minutes. And she's even changing her hair color with her brain and starts doing telekinetically, which is weird. Like, why should a smarter person be able to move things with their mind? That's not an obvious next step for being smarter.
Maybe the object feels intimidated by the brain power and just wants to get out of the room.
It just seems to me you solve problems faster.
Yeah,
That's
exactly.
all. Smarter people don't have telekinetic powers.
Yeah.
Right?
That's really true.
Right. And all the movies did this.
I am so smart. Toaster, come to me.
That's not a thing.
I was in Best Buy the other day, and there was a guy making TVs fly. It was crazy.
He was a really smart guy.
Right. So, but with all of our abilities,
So I'm intrigued by that branch of science. That's what started the question.
So 100 years ago, 100 years is a long time. Why haven't we been able to get to know more than 10% of the brain, 12%, 15,
Two reasons.
20%?
It's hard to study the thing that is giving you the thoughts to study the thing.
Oh.
It's very recursive, right?
You just blew my mind, man.
You want to hear another recursion? Recursion is very mind-blowing. You ready?
Yeah.
Because I recently got a word into the Oxford English Dictionary.
Did you
Did you
really?
know about that?
No.
Yeah. The Manhattan Henge was in there. It says, first used by Neil Tyson in 2003. I said, what took you so long? 16 years later, but I'll take it.
What's the word again?
Manhattan Henge. You know Manhattan Henge.
Oh.
Those are 2 days of the year where the sunset aligns on the Manhattan grid. And now thousands of people flood the streets blocking traffic. It's a great.
Oh my gosh.
Think about all the other reasons traffic had been blocked. There's an accident or construction or Con Ed is digging, New York's electric company. But now we stop it for the universe. I'm loving it. So anyway, so get a word. So here's what, you ready? Every word in the Oxford English Dictionary used to define every word is also in the Oxford English Dictionary.
Okay, so if I look up a definition of something...
All the words they assemble to define that word are themselves, each one of those is in the Oxford English
So
Dictionary.
it's not possible to have a word in there that is not in the dictionary, but is indeed a word.
Because then That's why it would be in the dictionary defined.
But how do we know that they have it covered?
We don't, but what we do
And
know...
I'm not even being funny there. You know what I mean? Like, you got a limited group of people.
We don't, but we know that they have it covered better than anyone else. It is their singular mission in life to record every use of every word.
Yeah, but you're biased. You got a word in there. You're gonna kiss their rear end all day. Oh, you're so smart, the Oxford Dictionary people.
I didn't say they succeed at this. I'm saying this is their mission statement, to have every usage of every word ever in the English language. So if a word first appears, they have the first appearance of that word. If you use that word slightly differently, pivoting its definition, that usage is then given.
Oh, wow.
You just pivot it again, it's given. Yeah. There it is.
And this gets back to the point about the brain, because the brain, we can get only to 10% because the thoughts that you need, it's that.
No, forget the 10%. It was misinformation from the very beginning.
No, I understand that. But when I asked about, well, why can't, with all this.
Well, it's one of the challenges. Right. How do you study the thing?
That's right.
That is the thing that's studying the thing.
Right.
A. B, you can't just sit there and operate on people for scientific experiments. You know, Paul, I want to know how you think. So can I remove your top part of your skull and put electrodes in your brain just for my science experiment?
How much would you give me? Would you take over my mortgage? I would very happily have you open up my skull, my tiny skull. Which,
size 6.5. We got it.
Okay, exactly.
So another question.
There's a follow-up to this, which I think is
a follow-up. Go.
Why doesn't the matter in Saturn's rings accumulate like the matter in a protoplanetary disk?
Oh.
I know the answer to this because it gets cleaned once a week by a guy with a shop vac. Anyway, go ahead.
Yeah, no, that's not there. So the matter in Saturn's rings are very thin, and they're small particles, and they're very thin. And the matter does collect. It collects into certain zones, clearing out other zones. So in fact, Saturn's rings have gaps in them.
Which you kind of see.
You can see with a medium power backyard telescope. And in fact, it's not just simply a gap. You can see like the ball of Saturn through that gap when it's at the right angle. Right. So you know there are no particles there, or at least very few. So they collect, not in a sphere, but they collect orbitally, all right? Because they have stable orbits around Saturn, and they're not much mass there to begin with, they're not going to overcome this orbit and then coalesce into one moon, for example. When our moon was created, we had a ring. That whole ring collapsed into a moon because of huge chunks of material that were there, whose gravity wins. And it's winner takes all. If you have slightly more gravity than this other object, you will attract slightly more material than this will.
And those larger objects in what was the ring around the moon came from just sort of...
No, Earth had a collision. Earth, we were sideswiped by another planet.
Right.
And our Earth's crust got spewed into orbit around us, into a ring, and that ring then coalesced into the moon. And so there you have it. So one of the most depressing things I learned, because I'm not an orbital dynamicist, so I'm reading some papers from some colleagues, was to learn that Saturn's ring system might just be temporary.
Why?
Well, because they track the orbits, and the orbits are not stable, that you're losing them down into Saturn itself.
Getting sucked
Yeah.
in.
Suck. That's the second time using this word, suck.
Is that right?
Gravity is pulling them in.
I'm sorry.
Bring a new sentence to your...
Wait a minute.
Saturn sucks.
Why? Because suck's not in the Oxford Dictionary? Is that why? And when do they anticipate when that might happen, that those rings disappear?
Well, so they suspected that it's a 10 million year or so lifespan, which would mean the dinosaurs, if they had telescopes, Saturn would not have rings for them. Because they were 60 million years ago. They were longer ago than Saturn's rings would have. Yeah.
So the rings developed.
I feel sad. Yeah, I'm just saying.
I'm going to miss those rings. Those times we'd had together.
In 10 million years. Okay, next question.
Okay, here we go. This is from Carcella Bonisior. I'm sorry if I'm butchering that. This is from Twitter. Since Jupiter is 90% hydrogen, can we tell it's a failed star, if it's a failed star?
Ooh, yes, we can tell if it's a failed star, but you won't learn that until after this break.
Wow.
See what I did there?
There you go.
Is that good? That's how the pros do it, right?
Good.
Right? Okay, when we come back, we will find out whether Jupiter was a failed star on Star Talk.
Thanks to the following Patreon patrons for helping us make our way across the cosmos: Tom Hernkey and Jonathan Gaffers. Thanks so much, guys. And if you would like to get your very own Patreon shout out, head to patreon.com/StarTalkRadio and support us.
This is Star Talk.
We're back. Cosmic Queries, planets and stuff. Paul, we last left off, yes?
Yes, we had a very interesting question from Twitter, and this is from Saracella Bainsaru. Since Jupiter is 90% hydrogen, can we tell if it's a failed star?
So she knows that the sun is 90% hydrogen. So these big gaseous things out there basically have their birthday elements in it. Oh, the universe's birthday elements. 90% of the universe is hydrogen. 90% of the atoms of the universe are hydrogen atoms. About 8% are helium atoms. When you see that ratio in big gaseous things, they're mostly made of stuff the universe was born with.
Mm-hmm.
So if stars are made of 90% gas, and Jupiter is, could Jupiter have been a failed star? Sort of.
Why? Because it was on Dancing with the Stars?
Is that where all the failed stars go? Does that joke still have currency? People still talk about that? People whose career, they need a boost, so they go on Dances with Stars?
So,
yeah, okay. I'm asked all the time to be on Dancers with Stars.
Oh, you have to go.
No, I'll tell you why not.
I want to see you in tights and the mass and the volume.
You want to check out my density, that's what you're saying?
But I remember talking about this on my podcast. You danced professionally or semi-pro. You're like a trained dancer when you're
I was a performing member of 3 dance companies, but they were like college troops. They were not. It was not the Bolshoi.
Once you got it, you got it.
But that was a chapter of my life, long gone.
Okay.
I'm not thinking of my present and future and saying, "Gee, I should dance again." These are not my thoughts. When I was dancing, I was not writing books. No one was publishing my essays. Okay, so Paul, take kindly the counsel of the years, gracefully surrendering the things of youth.
I think you should dance.
After all that I just told you, that's the best you could.
Just listen to what I tell you to do, please. So you have a possibly a failed star. Is what?
Oh, sorry. That's what we were talking about.
Yeah,
Thank you. So Jupiter, had it been, I forgot the latest numbers on this. Had it been maybe 5 times more massive, somewhere around between 5 and 10, it would have been a star, and we would have had a double star system.
Why does that size suddenly make it a star?
Because the bigger you are, the higher the pressure is in your core. Because there's more mass, there's more weight, there's more pressure. And when you have pressure in the core, the temperature rises. And as the temperature rises, there's a threshold where you start fusing nuclei in the presence of heat. Thermonuclear fusion. That's where you get that word from. The sun is undergoing thermonuclear fusion in its core. The high pressures, high temperatures are squeezing together hydrogen atoms, and out the other side comes helium atoms. And the helium atom has less mass than the hydrogen atom. Where did the mass go? E equals mc squared. It became energy. And that energy is sustaining the star. Jupiter didn't have enough. Didn't hit that threshold.
And forgive me if this sounds like a silly question, and I'm being serious. If Jupiter's 90% hydrogen,
Yes.
is it just this ball of gas? Could I fly through it, or would I hit?
Yeah, so there's no surface.
Something.
Right, so you fly straight into it, and you just keep plunging down, but you start feeling higher and higher gas pressure above you, and eventually you get squashed or vaporized, depending on whether you hit a hot zone sooner than a high pressure zone. So it depends on how resistant to pressure you are. That could get you to deeper, if you have a vessel, for example, they could get you to deeper places where it's even hotter. So Jupiter did get hot in its core. Oh, let's not be unclear about this. It did get hot, It just didn't get hot enough to hit that threshold of
right.
thermonuclear fusion. It would have been fun to have 2 suns, though, in our solar system.
What would that have been like for us?
Bad.
A lot of sunscreen.
As you go around the suns, you're closer to one at one point and then not so close to the other. That can wreak havoc on the stability of your climate.
Mm-hmm.
Also, it wreaks havoc on the stability of your orbit. Where is your orbital allegiance today relative to yesterday? Never good for orbits. Your orbits go unstable and you fall into one of the 2 stars or you get flung out into...
I say that all the time. It's never good for 2 orbits. I mean, but never good for orbits.
Next question.
Next question. Okay. This is Ulysses Lindblad, Twitter. Do you get high and low tide on the northern and southern poles?
Ooh, very good question. I never thought about that. So let me think about it now for the first time, and I'm thinking no. Because the bulge, you definitely wouldn't in the first day of spring and first day of fall. Because on those 2 days, the poles are sideways to Earth. And the tidal bulge is a bulge of the ocean, of the water mass of the Earth. And a tidal bulge, it bulges both towards the moon and away from the moon. So it bulges in both directions. Okay?
Moving this way.
This way, correct. That's why there are 2 high tides. That's why there are 2 high tides in a day. Right? Do you ever?
Oh yeah, I know. Because we go boating.
You go boating.
Yeah.
There are 2 high tides in the day.
Why? I don't know.
Because it has 2 bulges. One. So here's the moon off to the side.
Right.
There's a bulge that's closest to the moon and a bulge that's opposite the moon.
Okay.
So you say, well, if the moon is tugging on it, how could it bulge the other way? Here's what's happening. The moon is tugging on the water and on the Earth. So it's tugging. The closest water gets pulled the most.
Which makes low tide.
Only on the sides of this, because the water got sucked out of the intermediate places on Earth. The point that points towards the moon, that's closest. It feels the moon's gravity the greatest. Then it's Earth that feels it next greatest. Then there's the side of the water on the other side of the Earth that feels it the least. So there's an elongation of the entire system in the direction of the moon.
And
these are called tidal forces, tidal stretching. Earth has goes through tides. They're not as high as the water, but Earth, the solid mass of Earth, actually stretches in this way. So as Earth turns once a day, it goes through 2 high tides. Now, these bulges come out from one side of the Earth and the other. Okay, so the size of your tides are affected by several things, but also sort of your latitude, yes, on Earth. I'm expecting that the equator will have higher range between high and low tides than other latitudes would. But there are other factors that affect it. Do you know the highest swing in tides is the Bay of Fundy?
Why?
Bay of Fundy, because there's is it a fjord? It's a very long tract of land 2 sides of the land that has a long, I think it's a fjord.
Mm-hmm.
And so what happens is, the tide comes in, and the slope is very shallow. So if the tide goes up a foot, it goes in a half a mile.
Oh.
It's really cool. So you can run alongside the tide as the tide is coming in.
Because it's so shallow.
It's so shallow. And so the tide, when it goes up a foot, it's going to go up a foot. But if to go up a foot means you have to go down shore a mile, that's where it's going to be when it goes up a foot. So the movement of these tides creates friction between the waters and the Earth. Mm-hmm. And the height of the tide, I think, is not so important in that case, as much as how much the tide moves and how much friction Earth feels against it. And do you know this friction between the oceans and the tide is slowing down Earth's rotation? We're in the stuff part of this broadcast.
Why is it slowing down the rotation?
Because I left something out. This tidal bulge that I said aligns with the moon, it doesn't.
Don't lie to me, man. Don't play with me.
I have to lie to begin the explanation. Otherwise, it's TMI. Okay? Do we understand what I just told you, that the moon stretches this whole system?
First of all, stop yelling at me.
Okay.
No, I'm just kidding. Yes, and
Okay.
can I just say it quickly for my own? So we're on the East Coast, the Atlantic Ocean. So and we're in New York City. So when when this side of the Earth that we're on is sort of aligned with the moon, that's when you're going to get low tide because it's pulling.
No, if we're aligned with the moon, it pulls it, and we're going to get high tide.
I'm sorry, it's pulling it right. Okay, got it. Okay.
Now, you want to know something interesting? When you're at the beach, we say, "Oh, the tide's coming in, tide's going out." That's not what's happening. The tide is just always there in space.
Mm-hmm.
You're on the solid Earth, and you're rotating through the high and low tides.
So if I picked a spot in the ocean, the tide is always that level?
No, not a spot in the ocean. You pick a spot in line between Earth and the moon. Pick that spot. That'll always be water at a certain height. It'll just be there. And Earth, that whole system, and Earth, the solid Earth, is rotating in that.
And so when we're in it, it feels like high tide. And
when we're in it, we say it's tide coming in and out, but it's Earth rotating into a high tide bulge and out of a high tide bulge. Wow. Yeah.
Does the
it's
water
pretty cool.
get displaced?
So it's the illusion that something's coming towards us and away from us. It is you are rotating into it. And so now, I said it lines with the moon. It doesn't. It's ahead of the moon.
And why is that?
Because Earth is dragging the tide. This whole bulge wants to align with the moon, but Earth is not letting it. It's pulling it in front. So the tidal bulge is ahead of the moon.
It's gravitational pull, right?
See,
I didn't use the word suck.
No. It's the friction between Earth and all of this water that is shoving the water ahead of where the moon is. And the moon is trying to resist this by pulling, come back to me, tides. Mm-hmm. No, I'm pulling it ahead of you. This battle between Earth and the moon is slowing down Earth's rotation. It is the source of the occasional leap second that is thrown into the calendar.
Because it's slowed down by this process. Because
the moon is making the tides, and the tides are resisting what Earth is trying to do.
And what would Earth be like if that did not happen? If
we didn't have tides?
If it didn't get slowed down by this friction that's happening?
If we didn't get slowed down, then the duration of a day would be stable, but it's not. The length of the day is increasing very slowly. You're not going to notice it, and you're not going to care. But clocks care. GPS satellites care. That matters.
But every day isn't 24 hours.
No,
per
not
se?
anymore. It's slightly longer than 24 hours. And rather than increase the length of a second, which would create its own problems, we just say, wait till that increase accumulates a second. Then we just throw one in.
And that's the leap.
So on the leap second years, the last minute of that year has 61 seconds in it. Just to make up for things because of the tides. Because we are dragging ourselves through high tides and low tides in space.
This explains why I'm always late. The tides. Thank you. I got to the bottom.
Paul, did we only get through 4 questions? One quick one, quick.
Okay.
Because I think we've actually run out of time.
Okay.
Let's try. I'll give a soundbite answer. Ready? Give it to me.
Okay. This is from Tropical Troy 68 Instagram. Hello there, guys. I love the show. Can you tell me what U.S. taxpayers gained by going to the moon 6 times from 1969 to 1972, other than a bag of rocks?
Oh.
This is throwdown time.
Hold me back. Hold me back.
I can give you another question.
I said I was only going to give a soundbite answer. Here it is. You ready? So, I could speak on this for an hour, but I won't. I'm going to speak on it for 1 minute. When we went to the moon to explore the moon and turn around and photographed Earth, we discovered Earth for the first time. All major environmental legislation that exists in this country is traceable to the years that we were landing on the moon. We went to the moon to explore the moon, and we discovered Earth. Oh my gosh. Earth, not as your schoolroom globe showed it to you. No, not with color-coded countries. No, Earth as the universe intended you to see it, with oceans and land and clouds. And we're all down there together. It is the greatest of the gifts of the cosmic perspective that we have ever received. Only when the photo of Earth from the moon was published, she would say, hey, wait a minute, maybe we should ban leaded gas. Maybe we should ban DDT. Maybe we should clean up the Earth. Maybe we should clean up the water supply. Maybe we should clean up the air. Maybe we should protect species. There were some versions of those acts that existed earlier, but the comprehensive version where everybody's behind them, that all happened. 1969, 70, 71, and 72. The Environmental Protection Agency was founded in 1970. We're still going to the moon. So I ask you, what is the universe and the cosmic perspective it provides worth to you? This has been...
I'm intrigued and frightened at the same time.
I've been your host, Neil deGrasse Tyson. Paul Mecurio, co-host.
here.
Thanks for being on, dude.
Absolutely.
As always, until next time, I bid you to keep looking.